All right, so I listened to a number of y'all talking to me, and apparently, odds are difficult. Yes, odds by themselves are not difficult. Odds mixed in with probability is difficult. Okay, so I'm going to try to walk you through most of this. What I'm going to do is I'm going to do a number of the examples from today's sheet. Sorry, you'll be seeing this tomorrow. Doing a number of these examples from yesterday's sheet. And what I want you to do is look at it again, and if it clicks better now, fix that. Also, you have until next week to tell me, hey, I need to redo this test because I don't like it, or this quiz, or even one of the e-learning assignments that need to get redone. Anything you need to get finished, you have a huge opportunity because you have a whole week of nothing happening except reviewing stuff and improving your grade before the quarter. So today I'm going to just show you the exact same stuff we did before. We're going to leave compound probability until we get back, until e-learning gets back on track the week after this coming up week. As my son likes to say, we have a pre-spring break, spring break. All right? We're going to get through this. It's going to be fun. You have a unique advantage. I'm going to just recommend, especially those of you that aren't redoing anything, even if you are, spend the next week really reviewing probability and odds. If you, the whole rest of the class, all the way until graduation, focuses on really understanding and using probability. It's not all difficult. Some of it is, but it's what it really is. So if you spend a week like reviewing stuff, if you spend the whole time looking at other people on YouTube and all the other good stuff, whatever it is that you find, if you like, you want to send me emails asking me questions, we'll do just probability, just get the basics really, really down pat. And then this should be fine. All right. So this first little marble thing, the sample space, so basically, like if I'm picking one marble, the sample space is every single marble I could get, right? This is the picture form of the sample space. For us, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 marbles. All right. Wow, that looks bad. Hold on. I am focusing the camera right now, by the way. That's what I'm trying to do is... Wow. Okay. That says marbles. All right. The big thing is, like, that's a blue marble, and that's a blue marble, and that's a blue marble. Just because they're the same thing in my mind, if there's more than one of them, they count more than one times. All right. The probability of it being blue, 1, 2, 3, 4, 5. The 5 marbles I labeled blue. The reason why some of these got labeled and they were different shades is when I first did this, I had a really old projector, and the colors got all blurry, and it was really big mess, and basically it looked like there were only 4 different colors. And I made it using the projector, and it ended up looking like there were only 4 different colors. Apparently I was picking different shades and didn't realize it. So there's 5 blue marbles, so there's 5 ways to win out of the 22 ways I could grab a marble, right? I could have grabbed that one, I could have grabbed that one, that one, that one, that one, that one. 5 of them would have been counted as a win, 22 would have counted as losses. All right. Now the odds in favor of blue, that is the 5 ways I could get what I wanted. 2 means big fat colon. Lots of jokes there. We're not going to say them. Now, if there's 22 total marbles and 5 of them are blue, that means the other 16, 17 of them are not blue. Right? This is total possibilities. 5 of them are blue, 17 not blue. What I'm writing down right here is not blue. Wow. So the odds against blue, that means that I'm rooting against blues to win. Well, there's 17 ways that blue could not be the winner. Colon, 5 ways that blue could be the winner. Hopefully that's making a little bit of sense. Flip. Alright, I think I'm going to go to the actual board for this. Oh, because it's hard to read. That's not any fun. Pollen. I'm not dying of anything. Just pollen. Pollen is not my friend. So there's 15 names in the math drawing. Alright? 4 students are from Poway High. Alright? Poway has 4 students. 2 students are from Glendale. By the way, anytime I'm doing this probability odds stuff, it's really, really helpful to either make a picture of the stuff or to pull out the information. I don't know about y'all, but like, if I don't see it in a paragraph, it's a whole lot easier for me to get what I need. It might be why I'm a math teacher. I like tables and graphs more than I like paragraphs. Alright. 1 student is from Hilltop High. That's the other thing. Like, they switch up the order between the numbers and the places. So, sometimes it's helpful to deal with that right there. 5 students are from Midland High. Lost my spot. 3 students are from Pacific High. Mr. Martinez draws a name without looking. Find the odds. So real quick, we want to know how many total students there are. That's going to be helpful for any probability stuff, except there's no probability questions until the next section. And it's let you know how many are not there. So we have 4 plus 2 is 6. 1 more is 7. Plus 5 is 12. Plus 3 is 15 students. Alright, I'm just going to grab every other one, so we should be alright. So the odds in favor of the student being from Hilltop High. Well, Hilltop has 1, right? And there's 14 that are not from Hilltop. That makes sense? So the odds in favor of them being from there are 1 to 14. 1 to 14. Yay! Alright, number 3, the odds against the student being from Pacific. Right? So Pacific had 3 students, and that's what I don't want. I'm against Pacific. So there's 3 that make me get sad. The other 12 are okay. That makes sense? There's 12 ways to be against Pacific. Those 6 and those 6 makes 12, and 3 ways to be for. Now, that reduces the way ratios reduce. 3 goes into both of them, right? So 12 divided by 3 is 4, and 3 divided by 3 is 1. That makes the odds 4 to 1 against Pacific. Number 5, odds against. All the odd ones odds against? No, okay. Oh, almost wrote it off the screen. Odds against Poway. Right? Well, there's 4 from Poway. Right? Out of the 15 total, that means that there's 11 that are against Poway. And 11's prime, so that's not going to reduce any. Does that make sense? The thing I hated most about this is I can't get like live feedback. I need some people to get into the Miro board tomorrow and actually ask me. I say tomorrow, I mean today. When you're seeing this, it's today. I need some people to get in there and like actually ask me questions, just to have a conversation with someone that's not 7 or in middle school. Odds against by the way, this is number 7, in case you lost track. Against the student being from a school that starts with the letter P. So, if I am against the P's, that means Glendale's okay, Hilltop's okay, and Midland's okay. So there's 3 and 5, that's 8 that are okay. And that means they are not, and they are not, and 7 that are not. Hopefully this is starting to make sense. If it makes you feel any better, Mr. Caldwell is like one of the best math teachers I ever knew, and he hates probability, and not because he just doesn't like it, but because in his words, he's just never been any good at it. Odds in favor. All right, let's see what we're cheering for now. In favor of Fremont. Great. You ready? Fremont is not there. And this is a special case. There is nobody in favor of Fremont. Now, there's 15 that are against. And I can reduce that. The biggest number that multiplies to 0 and 15 is 15. 15 goes into 0 times, and 15 goes into 15 once. In fact, anytime you have 0 on one of the sides of your probability, it'll always reduce to either 0 to 1 or 1 to 0. If you had 635 to 0 as your fate odds, I can't talk, that would reduce to 0 to 1. Not what I just said, what I just meant. That would reduce to 1 to 0. That's off the screen. It's a cool thing. It's just like if I had a fraction that was 0 over 10, but I had to keep it a fraction, I'd reduce it both by 10 and have 0 over 1. Don't get freaked out about that. Too many students get freaked out about that, and it makes sense if you think about it correctly. It makes no sense if you don't. Welcome to math. Okay, that's 9. We're going to do number 11. All right, the probability that the student is from Poway. I'm just going to write it POW. There's 4 that are from Poway and 15 total students. Number 13. Probability the student is from Glendale or Midland. Right? Glendale has 2, Midland has 5. That's 7 ways I can get what I want out of 15. That makes sense? Oh my gosh. This is going to be like the longest video ever. 15. Hope I didn't skip. No, I didn't. Students from Pacific. Probability they're from Pacific. Pacific has 3 students out of the 15 total, but that reduces because 3 goes into 3 and 15. 1 time 5. 3 goes into 3 once, 3 goes into 15 5 times. Let's do 17. I'm doing too many of these for you. Probability. Oh, the complement of Midland. You ready? Midland. Not that way, guys. Not from Midland. Well, you ready? 1 minus. There's 5 for Midland. I'm doing this differently just because I was getting bored. Alright. 5 out of 15 are for Midland. By the way, I'm just going to go ahead and reduce that. That's 1/3. 5 goes into 5 one time. Okay, 5 goes into 15 3. And 1 minus 1/3 is the other 2/3. Because that's how I wanted to reduce it. You could have done that a whole lot of different ways. You could have counted up all the ways that weren't from Midland. 4 plus 2 is 6, plus 1 more is 7, plus 3 is 10, and have 10 over 15, which reduces to 2/3. Doesn't really matter how you do it. Alright, I don't know which page was next. The Susie Owns Marbles. I really hope this is like getting to you now and you're starting to catch it. Susie owns 2 black marbles. Let's see. I think I have some colors.